Lab1 of EE542. Here I'm going to explain the server code. So let's open the server code. This is our server code. These are the headers that we have used. And here system/types.h contains definitions of a number of data types used in system calls. sys/socket.h includes a number of definitions of structures needed for sockets. net/in.h contains structures needed for internet domain address. And the main function, we take in the command line inputs, and these are the variables and buffer. In the buffer we store whatever we read from the socket, and this is the port number. Here we use A2I to convert from string to integer, and argv1 as the second input in the command line. And here we use the socket system call to create the socket. AFINIT tells that it belongs to internet family, and sockstream tells that it is a TCP socket. And here we define the structure for the server address, which contains three members, that is SYN family, SYN port, and address. The family is internet family, and we use H to NS to convert to network byte order. That is, we convert the port number to network byte order. And the address, we use INADDR which chooses the relevant address, that is the address of the host where the server is running. And then we use the bind system call to bind the socket which we just created with the server address. Again, the address contains the IP address and the port number. And then we use the listen system call to listen on the socket which we just created. Here we keep the backlog queue as 5, which is the maximum limit. Then we use the bootup message to know that the server is up and running once we start the server using /server command. And we use the infinite while loop. For here the server will be listening for new connections, and we use the accept system call to accept connections on this socket, and we store the address of the client which just connected in client address and the length in cli_len. And if we fail to create the connection, then that is the validation check, and we use the read system call to read from the child socket once the connection is successfully established. This is the validation. If read fails, we print that there is an error in reading. And then once we get the message from the client, we send an acknowledgement to the client saying that I got your message. Then we close the child socket. Then we close the parent socket. Now let's run the client code which is on another host.
This is the client program. These are the header files mentioned in the tutorial to be included for networking. This is the socket system call with AFINet family for internet domain and sockstream for TCP protocol. This is the connect system call connecting to the server address which is mentioned above, and we use get host by name for it. The commented part below is a system call called send and receive, which you can use for sending and receiving data as well. But we have implemented a write and read system call, which use the socket descriptor that we get from socket function, and we send and receive data through it.
Now let's start the server on one laptop. So we change the directory to where our server code is, and after that we use the GCC compiler to compile our code, and our executable file name is server. Then let's do ifconfig to get the IP address. So our IP address is 192.168.1.18, and we can see the hardware address as well. Using the IP address, the client can connect with our server. Then let's run the server, and the port number is 24790. The server is up and running and it's waiting for the client to connect. Now let's run the client program on another laptop. Let's go to the folder where our client code is, and for that you use the cd command. So the folder name is internet and cloud, and let's compile our client code using the GCC compiler, and the executable file name is client. Now using /client, let's start the client, and we give the IP address of the server, which I told earlier. It's 192.168.1.18, and the port number at which the server is waiting for the client to connect, that is 24790. And let's enter the message welcome to EE542, and the server reverted back with I got your message reply. Let's go to the server and see whether we got the message. Here the server is up and running and waiting for the message from the client, and we received the message from the client, welcome to E542. Now let's talk about UDP sockets. First I'm going to talk about client UDP sockets. It's pretty much the same as TCP sockets, but while creating the socket, wherein we use the socket system call, we use sock dgram instead of sock stream. Sock dgram means we are using the UDP socket, and the third argument, which is 0, tells us that it chooses UDP protocol by itself, and everything else is the same. But instead of using connect system call, we use send to system call, wherein we pass the server address as well. In the last two arguments, we pass the server address and we pass the size of the server address. And in the receive system call, and we use the receive from system call to receive from that particular socket, we pass the server address there as well. Now let's talk about the implementation of UDP sockets at the server side. It is similar to the implementation of TCP sockets in the server with few changes. In the socket system call, we use sock dgram as the second argument to show that we are using UDP sockets instead of TCP sockets. And we use the infinite while loop, and we use receive from, wherein we receive data from the socket and store it in final receive buffer, and we store the address of the client in client and its length in len, and we use send to send through the socket, that is the UDP socket, and we send the address of the client over there. Now let's talk about implementing fork at the server side. This is similar to implementing TCP sockets at the server side. Here in the infinite while loop, we keep the except system call, and we use PID equals fork to create the child process. By using fork, we can accept multiple connections at the server side. If PID equals 0, then it's a child process. Then we do stuff such as read and write, and we close the initial socket, and the child process, when it's done, it dies by itself, else the parent process closes the child socket and it goes back to the except statement, wherein it waits for further connections. By using fork, again we can accept multiple connections. Thank you for watching this video.